This is test ID 41, component ID 00, and component ID 80. It's the EGR flow test. Component ID 00 indicates a maximum limit which would be used for locating excessive EGR flow. Component ID 80 indicates a minimum limit which would be finding low EGR flow. Now the PCM monitors short-term fuel trim when EGR duty cycle is changed. When EGR duty cycle is changed slightly, short-term fuel trim should have a slight change. Now, if EGR is duty cycle is changed slightly, and short-term fuel trim does not change, we have low EGR flow. If it has a large change, we have excessive EGR flow. Now, special note, this test does not operate properly until the engine's over 180 degrees Fahrenheit, where fuel trim is fully operational. Secondary fuel trim does not occur until we get to between 165 and 180 degrees Fahrenheit. The values aren't converted into measurement values by Chrysler, so use the data as a relative indication of performance. We'll use vehicle data to see our typical values. Now here's test ID 41. We have two CIDs. The CID for max says the max limit is 251. The CID for minimum says it's 15. Our actual test value for both CIDs is 51. Now what this is telling us is that we're well above the 15, so we have good flow, and well below 251, which says it's not excessive. If you have results like this, you're finished. You're stopped. You have good EGR flow. But if you have a problem, here's what you do. If the 51 for a test value starts approaching or goes below the 15, look for causes of low EGR flow. Insufficient vacuum applied to the EGR. EGR that is not working properly and has abnormally low flow, or restrictions in the EGR passages. If your test value approaches or exceeds the 251, look for an EGR that is coming on excessively and is no longer working properly, or look for high exhaust back pressure causing EGR flow to be higher than normal. Now, EGR duty cycle is not easily located in scan data. Most of the scan data tools we used, none of them showed us EGR duty cycle on a consistent basis. And we wanted to graft EGR against short term, we couldn't. So we used a grafting voltmeter and we grafted EGR duty cycle and map sensor voltage, since we couldn't tie EGR and short term together in time. Now our assumption here is EGR flow will affect short term, it will also affect the map sensor. So we're using the map sensor in this case. We're going to go look at some typical data. We had a vehicle, we had on a steady cruise, 30 miles an hour, fairly level road. Remember, any change in throttle position will change map voltage. So try to hold a steady throttle. You only have to hold it for a few seconds and do a little and observe what's happening to the EGR duty cycle. This took us about 20-30 seconds to run this test. We started off our cruise. The grafting voltmeter showed us the two values, 32% for duty cycle, 1.9 volts for the map sensor voltage. Now, that's a good baseline for you. We need to talk about that. The duty cycle. We see typical duty cycles between 20 and 50, depending on the circumstances. Not very often below 20% once we've been cruising down the highway for a few seconds, the engine's fully warmed up. And we don't see much above 50. So here's our assumption. If we're well below 20, we have something causing excessive EGR flow because the PCM is barely opening the EGR and achieving the resultant change in map voltage in our test, or in short-term fuel trim, which is the case of the PCM monitoring this. So if we have very little opening causing the change, look for high back pressure or something causing excessive flow from the EGR. If the duty cycle is up around 60, look for something causing low EGR flow. Low vacuum applied to the EGR. Restricted EGR passages. Plugged up EGR itself. Let's go back to our test drive and start driving down the road and see if our correlation is what we expect it to be. Shortly after we started off, we moved from 32 to 33, and map sensor voltage went from 1.9 to 2.0 volts. Later we're up to 35%, and it's making these small step changes as we drive down there. It did not gradually change from 33 to 35. It made a step change, and we saw a corresponding step change in map sensor voltage, 2.1 volts. Later up to 36%, we saw it change to 2.3 volts. Now you see what we've done? We've had a 4% change in duty cycle and a 0.4 of a volt change in map sensor voltage. Small changes in EGR duty cycle wound up making small changes in map voltage. If the changes in map voltage are excessive, we have too much EGR. If they don't exist, we have too little EGR. Later on, we start backing down, and we go back to 35% and go to 2.2. And later on, we get to 34%, and we're back to 2.1. So we see map sensor voltage going up and coming down with duty cycle. This is something you're going to have to watch with voltmeters, particularly a grafting voltmeter. It's very good for this job. This is the best way we have of judging EGR operation. But remember, Mode 6 is going to tell you when you need to take the time to do this test. If you're in the middle of the spec, trust Mode 6 and go on and test something else.